Could
We
you
don't.
repeat it, please?
So the question is, do you have anybody on the team currently working on AI problems? Maybe some of the standard, optimization problems, things like that.
Filters, stuff that
Right.
works in sense.
The short answer is no, not really. Our focus isn't on AI, but we think Holochain is a general compute enough engine. It's good enough for general computing that we'll be able to do a lot of AI related stuff. And
Structurally aligned with a specific class. That's why I was asking.
okay, gotcha. But nobody's
doing that.
focused on AI right now. In fact, I think the orientation of some of the founders like me, even though I have a degree in AI, I'm more interested in integrated intelligence where humans are a part of the data flow and interactions than something.
That's what I talked about.
All right.
Like sensor fusion of human behavior, like the signals are the people's behavior.
Right. So he says that's what he's talking about. And so in that sense, yes, we're trying to have emergence intelligence, but it doesn't feel like artificial intelligence in that sense.
Basically swarm intelligence implemented.
Yes.
Again. Okay.
Yeah, exactly.
Cool.
Swarm intelligence. Context.
Was there another?
Oh, another question? Sorry.
Any financial market or decentralized exchange?
We have a few groups that are looking at building decentralized exchanges on Holochain. I think one has started prototyping on the Go version. Most are waiting for the Rust version. You're going to hear me mention this a few times tonight. If you don't already know, we've rebuilt Holochain. We'd originally built it in Go. We've rebuilt it in Rust. I'm using the past tense, even though we haven't actually released it. Most of the features are built for running locally. A bunch of the network gossip, signaling coordination, peer-to-peer stuff is not written yet in the Rust version because we're doing a reset on that to basically to be able to be better at piercing gnats and firewalls than the old stuff that we were using. And so we're having to build a bunch of that from scratch, and that's not done yet. But the good news about the Rust version actually is it compiles and runs on mobile phones and tablets and that kind of stuff. So we have that in mind in the Rust we built.
There's another question.
Frederick.
If an app needs actually centralized, like common decision of all the participants, is Holochain not a good idea then, or can it also?
So if an app needs centralized commonization, what do you
like for example, like a currency or a joint decision of a large part of the participants, like a point where they do have to all be unanimous.
This is probably a question to get into when we get into a little bit more of the technical stuff. Many of you may know Holochain does not have a hard-coded consensus algorithm. We believe that most of generalized computing isn't rival data that you need to do consensus on. And if you carry that overhead for everything, then you don't have something scalable. We are building in some supports for assisting with the issues around eventual consistency, CRDTs, conflict-free replicating data types. If you guys are familiar with that, if you're not, we're going to talk about that later. That's in the design principles, green stickies over there that we'll get to. Other questions?
Hold on a second. I just want to announce we are live streaming currently. Congratulations.
But the camera's pointing this way.
Yeah, don't worry.
Yeah, maybe. Yeah, I can speak a little louder. Okay. Yeah. So one of the things that's going to happen a bunch this weekend, but also tonight, is we're going to do level switching, right? Like I was just stopping myself from drilling in too deep into conflict-free replicating data types and how it is that we actually deal with reaching certainty on an eventually consistent data store. I don't want to say consensus because it leads people to the wrong way of thinking about it, I think. So that was about to go into the micro, but we're also right now trying to stay in macro. We're going to be kind of jumping levels as we address different issues. And sorry if it feels like a little bit of a roller coaster, or if parts may go technical. Trust that we're going to come right back out again to some other parts that hopefully will be relevant.
Yep.
Cool. And then one other thing is it's related to the feel free to jump in, like surprise yourself, don't be afraid. Do not worry about looking stupid on building on Holochain. Nobody is a master on Holochain yet. Even as the architect, I'm still learning about ways to use it and to optimize things. And so it's not like anybody's making stupid mistakes. Like it's all still, it's still an exploratory pattern. So explore.
Arthur. I'm not a coder, but I know that all those wheels are invented already, like file share and all that, all exist in another language. Can you use it, or just everything has to be built from bottom up?
Pretty much everything has to be built from bottom up. When I say that, I mean I have yet to really see anything else out there that is built agent-centric. Almost everything is built on top of data-centric solutions. Most blockchain apps, most distributed computing tech, and obviously most centralized tech is designed to be centralized. And so if you want to build on Holochain as the underlying data engine for basically having distributed data integrity guaranteed by the cryptographic algorithms that we've got in place, then you have to rethink your problem. I have yet to see a problem that we can't build on Holochain that you can build on blockchain or something else, but you have to actually do some inversions in your thinking in how it gets done. What you can reuse is UI stuff, especially if the UI has been loosely coupled, or it's a web UI, that kind of thing. You can actually, we encourage, especially if you're building something right now, what we'll be building on this weekend is the Go version, since we haven't released the Rust version yet. And we can help you set up to be able to build UI components that can basically just plug into the new version. None of that would have to be rebuilt. And Michael can help you if you actually are sure that you're not just prototyping this weekend, but you want to start writing code that you want to carry over to the Rust version. He can help you set up actually to build that in TypeScript. The Rust version, our first language that the Rust version runs is WebAssembly. So all the languages that compile to WebAssembly are things that you can build Holochain apps for the Rust version. In the Go version, you can build in JavaScript or Lisp. Those are the ones that we've supported so far.
So I want to introduce a tool that's really helpful for us to get a sense of where the group is at. And raise your hand if you're familiar with video games. Excellent, this is going to go very well. So, raise your hand if you ever played The Sims. Okay, great. So in most video games, like in The Sims, they have a little bar on top of their head that's filled with some, I just assume it's a liquid, but it's just filled with something. In a lot of games, there's a status bar to indicate how much of something you have, magic, blood, life energy, whatever. And what we want to do is be able to tap into the group to check the group's collective status bar at different points, because it's really hard to see whether or not things are really landing for people or how people are feeling, especially in the tech community.
Let me just frame that. Eric's been working in education for a while and works a lot with kids who you get very visible feedback as to whether they're excited or bored or whatever. And to him, technical people always look bored. So
I'm getting a lot better at reading it. It's just subtle, but it's like great enthusiasm and complete focus can look like this. It's hard to read that. Your question?
Sorry.
Yeah, in case you want to download something.
Hang on, I'm going to keep doing this and then you get to your question. Okay. So what I want to do is get a sense of how we're tracking art right now. Like grokking what he's saying. Like how much of what he's saying is landing for you? Like, oh, I'm totally following this. This makes complete sense to me. I'm really excited. I want to keep learning more. And this is like I wish that I had had something different for lunch today. And this is all the space in between. So if everyone could just put a status bar up, I know it's hard, but you can do it. Great. So how much are you? This is level of tracking what's being shared right now. Like how much you're following. Great. This is really helpful to know. Like Art could actually up it a little bit more, and people are going to follow that a little bit better. So that's good.
What is UI?
He's joking with you.
Not really.
No.
Oh, really?
I was using jargon. So I was saying you could reuse the UI, that kind of stuff. Most of you probably know, but it's the user interface portions. Like a lot of the work in building things, building software for people, are actually how it's presented to the user. Those pieces you can reuse. There's nothing special about Holochain about that per se, except that we've designed it with the idea that if you're a web developer, that you can just use things that you're familiar with. You don't need to reinvent that wheel. So you can reuse those kinds of things.
Cool. Okay.
Should we go to the question?
Yeah. Yes.
All I wanted to know is if there's where do I find some download link? You mentioned the fact that there was.
Yeah, if you go to github.com/. Can you grab the mic back, Alexis, so you can type? Thanks. If you go to github.com/holochain/proto/releases, then, there you go. Then, anyway, that's the alpha releases. That you can just unzip that and run it straight from there. There's no special building required. The other link that we didn't give was chat.holochain.org is the online community with all those cool chat rooms I was talking about. Okay, context. So some people, it was great to hear in the introduction, some people have done some digging behind Holochain or known about us before Holochain. And so I want to just give a little bit of context for Holochain, in part why it's so different from blockchain and some of the other things that are happening out there is because it didn't derive from blockchain. It actually derives from other roots. And where what it comes from is the systems, the way that nature does systems, not just the way that we're used to doing centralized compute systems. Releases, do you see the 4 releases right in the middle of the page there? Whoop, right, down, middle, there you go. So the roots of this are a project called the Metacurrency Project. Metacurrency. Now, one of the things is we think of currency very differently. In English, we have these words currency and money that are largely used interchangeably. I do not use them interchangeably. When I say currency, I want you to hear something different, more like current, like flow, currency. The tools that we use, the simple systems that we create to shape, enable, and measure flows on a collective level. So money is just one type of currency for making visible exchanges of goods and services. College degree makes visible something else altogether. It's a formal symbol system. But it's like money, you don't get to issue money to yourself, right? If you do, that's called counterfeiting, right? You can create value, but you don't get to just create money normally, right? Now, then the whole crypto movement, you could say, is actually purposely a contradiction to this. This is trying to take back the ability to create new kinds of money. But the same thing goes for a college degree, right? You don't just get to give yourself a degree, and you get the degree by meeting the degree requirements. You need credits, and the credits only count if you get a good enough grade, and you don't get to give yourself the grade, and you don't get to give yourself the credits. All of these are types of currencies, types of symbol systems that we use to shape, enable, and measure flows in the educational space. And you can look at sort of the balance sheet by looking at a student's transcript and blah, blah, blah. That may be too much detail. The point is, the Metacurrency Project is about actually going beyond currency in the normal sense into this more currency in the symbolic sense, because we believe that currencies drive much of the intelligence of our social organisms, the way our institutions, governments, corporations, organizations work. And much of the way those things work are broken. And if we don't get better at making these currencies, they're going to stay broken. We're going to keep eating the planet like a cancer because we've created a currency that basically creates cancerous corporations, right? Like, I don't mean to go on to this into like a huge, into a huge ideological thing. It's really just about understanding the patterns and feedback loops. So the people that are into the patterns and flows, living systems design, that's the roots of this. Out of the Metacurrency project came a solution that we started building and we've prototyped a lot of for creating a quantum leap in our capacity to coordinate on these new levels. It's called Scepter, CEPTR. Short of it, Scepter is one of the tabs open over there, Matthew. It's called Scepter and is short for receptor because it's all receptor-based computing. And it turns out that if you want to build a computing model that is resilient and composable and flexible instead of like rigid and brittle, if you build it based on, I'm going to say, the feminine capacity, the receptive capacity, it ends up coming out completely differently. And so we built a lot of this stuff in Scepter, and the problem is Scepter is weird. Like, it kind of breaks your brain if you're used to thinking about computing the way it normally is done. And so it's hard to get people to adopt it because it makes you undergo almost like a dozen paradigm shifts in how we do computing. So we're not going to talk about Scepter tonight because I don't want to break your brains, but just stretch a little. But what we did is we took one piece of Scepter, basically the way multi-instance receptors synchronize data with each other across machines. We took that one piece of Scepter, built a standalone version of it called Holochain.
What Holochain?
So that's where Holochain comes from. Let's do the why at the same time. So let's do it really brief. So the why for Holochain for us is about being able to create these new levels of social intelligence. And you could say a new medium for encoding social DNA. And what I mean by that is like when cells created DNA such that they could organize multicellular life, there was an explosion of new patterns and experiments, many of which did not work out. You know about the Cambrian explosion of life forms, right? We actually think Holochain and Scepter is that kind of thing for us in the organizing, coordinating, communicating space, that we're going to create an explosion of new ways that we can coordinate on scale with each other. And some of them may not work out, but many of them will outcompete the ones we know, will outcompete what we currently know of as these sort of pyramidal hierarchical corporations, governments, that kind of stuff. They move too slowly to actually adapt in a fast-moving world.
I want to get a skepticism scale.
So if you're really skeptical about
This is bullshit. I don't believe you. And this is like, tell me more. Yeah. I want to see where people are. And look at each other. This is the big thing. It's not just for me. It's for the group to get a sense of itself. We're talking about collective intelligence. You really got to look around the
I
room.
protest your scale. Tell me more is here.
Tell me more, but it was the energy of it. Tell me more. I really want to know more.
Okay.
I gotta include the language. Thank you.
What?
Oh, what?
All right, cool. Yes.
Can I ask one quick question about Scepter? Are there other elements in the Scepter project that might be used in the future? Can you explain what that might be? Are there other aspects in the Scepter project that might be used in the future? And what would that be? What sort of things would you be thinking of?
Well, we definitely hope to use all of Scepter in the future. We hope to actually go back to finish building and spreading Scepter. But for us, I mean, just to tell the truth, Holochain is kind of a gateway drug, right? Do you know that expression, a gateway drug? We're trying to have people take one little minor brain-breaking step to agent-centric architectures and have that be a reason why they would suddenly go, wait, these guys actually figured out how to make something scale that nobody else was scaling. Maybe there's a reason to look at this other stuff. So it's our intention very much to bring, it's kind of an on-ramp, right? We want Holochain to be an on-ramp to more and more functionality. In particular, one of the really important things about Scepter is that we've built a protocol for protocols. We have made protocols actually pluggable, nestable, chainable. We built a universal protocol parser that enables this, but only if you set up the memory model that Scepter has. So we have these problems and these questions right now of getting technology to interoperate. And if you've been playing or you've been looking in the blockchain space or whatever, the question is, can any of these things work together? And mostly the answer is not very well. And so we definitely think that some of the things that we've created in that space are a direction we need to be moving. But first, let's take the first step. Okay, what is Holochain? So can you go back to just hit Alt-Tab to the big black screen? Sorry. There, oops. Okay.
I'll deal with it.
Okay. So, I want to start off talking about, actually we might as well just go to the core concepts while we do it. Yeah? So, Holochain is, whoops. Holochain is an inversion of the blockchain architecture. In fact, the more you know about blockchain, the more handicapped you may be at the moment in understanding Scepter. Like if you could just table your knowledge of blockchain just for a moment, set it aside, and think instead of Git plus BitTorrent, right? In Git, you have your own code repository locally, right? Now, many people use Git through a centralized thing, GitHub, but Git was designed originally to be able to be used completely peer-to-peer, but GitHub provides a lot of convenience. One URL we can all synchronize with, and some nice UIs and all that kind of stuff. But think for a moment that each person has their own chain, like you do in Git, have your own repo, and then imagine using something more like BitTorrent rather than GitHub, which is a centralized website, something more like BitTorrent to be able to synchronize pieces. That's a better way to think about the architecture of Holochain, probably, because, in fact, this is a hash chain, and this is a DHT, which is the architecture that BitTorrent uses. So there's a bunch of things that this gets us. But I feel actually like I need to back up 1 second and say why this matters and why distributed computing, I think, is stuck in certain places. Because, so, status bar, right? Bear said an interesting thing when he introduced the status bar. We're all doing our individual status bars, right? If I say, how excited are you to be here, right? We do a status bar kind of thing. Every person's going to do their own status bar. Bear introduced it as a collective status bar, interestingly. We can get a collective read on the room, but each state is a local state. It isn't actually a collective state, right? If you take the average of the status bars, that state doesn't live anywhere. There's no such thing as a global mood of us in the room, right? There's just a local mood, right? We have it encoded in our nervous system. There isn't the global nervous system that we can encode that mood in for the room at the moment. Is that making sense? Now I want a status bar on this. Does that last part make sense of what I'm saying? Okay, great. So one of the challenges is that blockchain and many other computing algorithms, our distributed computing algorithms, are trying to create global state, and now they have to manage consensus very strictly about global state. We're suggesting global state is actually a fiction. There's only local state. So the local state we structure in a traditional hash chain. So it becomes immutable. It becomes immutable because once you publish your hash to the DHT such that others can see it, then everybody knows if you go back and try to change something. Sorry, I'm realizing for the non-technical people, I'm probably skipping over a couple of key concepts. Hash chain, let's get hash chain up there. And so first, a hash, a cryptographic hash is like a fingerprint for data, if you think about it. And you have a hashing algorithm that will, if you pass the same data through, you'll always get the same fingerprint. If you make one little change, you have a 700-page book, and you change one comma to a period, the hash fingerprint comes out completely different. It doesn't look like the same fingerprint. It comes out quite unique. There's a bunch of other things about cryptographic hashes, but a hash chain is a way of chaining these fingerprints together. So we have this entry here we're calling DNA. This is the application code program that people write. We take the hash of that. This is the first header in this hash chain. Then we take your identity information. We take the hash of that and the hash of this header linking together, right? And we keep doing this, and therefore, if you were to go back and change one little thing in this code, then it'll break this hash, which will break this hash, which will break this hash, which will break this hash, because you'll get a different fingerprint all the way up. So when you fingerprint that data, it basically locks in all the past. This is standard hash chain type thing. Blockchain just does this in blocks of multiple transactions. There's a bunch of reasons why. But yeah.
Could you speak to what E1 and E2 use that on?
Entry 1, entry 2, header 0, header 1. I mean, if it was Clutter, for example, maybe the first thing you do is register your username, and then you do a hello world tweet, or, Clutter is our Twitter clone. So these are just generic, entries that you can put in the chain. These are our Genesis entries that always start off the same. This is always the first entry. This is always the second entry. First entry is, what space are we in? Basically, we call it the DNA. Boy, jumping all over the place. We call it the DNA because every Holochain application, we view it as an organism, with every node as a cell in that organism. The DNA is part of the encryption salt for how you talk to the network. So you don't talk to nodes that are not sharing the same DNA as you. You only talk to people playing by the same rules, right? So that basically share the same DNA. These are over the network. You only talk to people playing by the same rules. Locally, you can run two Holochain applications and have them talk to each other, but we'll come back to that. That's jumping ahead. DHT, sure. So this is a hash chain. The other concept is a hash table, which is basically a lookup table for looking up data by its fingerprint, right? It's a key value store where if you have the fingerprint of the data, then you can go and retrieve the data from that lookup space. The DHT is a distributed hash table, which is a way of breaking up that kind of lookup table across lots of different computers. So nobody has to hold the whole thing, and you still know which computers to go find the data on. And it actually can be pretty efficient and pretty fast. So Holochain is built of these fundamental components. And the reason it works, and the reason that it throws people off who think in terms of global state, is that you don't, so one of the big reasons that you need consensus in a global state is that you need to deal with time. If you've created a sort of an inventory of data, let's call them tokens or coins, right? So a token-centric approach or a data-centric approach, right? We want to know what coins exist and what changes are happening to these coins. And in order to validate these changes that occur, we also need to know something about time We need to know what order those things happen in, right? So blockchain, the reason people got really excited about blockchain was it was a way of randomizing, and when I say, I'm speaking now like when the Satoshi paper was published, it was a way of basically randomizing control of that timeline, right, with a way that's very hard to hack. And the thing is that in Holochain, you're not confused about time because changes are always local and they're always sequential and linear in somebody's chain. So if we want to do a transaction, sorry, in the inventory of coins scenario, if two people try to spend a coin, double spend problem, right? Then we need to know which one of those spends counts as first, and that's the one that we're going to make valid, and the other one is invalid. So we need some relationship to time there, and basically we need a global relationship to time because these coins live in a global state space. If the way that we recommend that you implement currencies on Holochain, you could implement tokens on Holochain, but you would have to implement your own consensus algorithm for them. The way we recommend you implement them is agent-centric. So we talk about Holochain being agent-centric instead of token-centric, and what that means is the state is always encoded in the agent. Think of this as your bank account history. You're just doing accounting, and your entries are transactions coming in or out of your account, right? So if we want to do a transaction, if Dom, is that your name? Dom and I want to do a transaction. We send each other a message and construct the transaction that we're agreeing to. Then we each sign it to our chains, our individual chains, and hand each other the header, which contains our signature. It's basically the proof that we signed it to our chain. So meanwhile, if Bear and Ken are doing a transaction, right, we don't care when their transaction happened relative to our transaction because the only two states that changed were ours. Why the heck should we get consensus from everybody else on the network if the only states that are changing are ours? And there's no ambiguity what sequence that happened in, and it doesn't matter what sequence it happened in with their transaction, right? So we don't need global time to be able to actually resolve currencies. And I kind of, I sort of jumped macro, micro, and I kind of jumped in here at a level of overview because I was watching some skeptical faces, and I thought, okay, I'm going to just go deeper so people can get the reason why. But, sorry, Frederick, do you want to ask a question?
If I understand correctly, that the currency doesn't exist as an entity itself, but only as in what everyone has and exchanges with each other.
So Frederick's asking, do I understand this correctly, that the currency doesn't exist as a thing in and of itself, but only exists in, I'm going to phrase it a little bit differently, as agreements between each other? I would suggest that that is the nature of all data. That actually one of the problems that we have all right, so some of you may have seen a rant that I posted online once about the problem with distributed computing is that they're stuck in two fallacies, that data exists and time exists. In other words, that data has some independent, primary, first-order existence, and that time has any kind of absolute sequence, right? We basically, the time one is kind of easy. We know that that's not true. We know that different people will experience events at different time because change takes time to propagate. There's no absolute sequence of events. There's only a sequence of events from a particular vantage point. But I would suggest the same is true for all of data. That if I were to ask you right now what the temperature in the room is, what would you say? Cold. I wouldn't say that at all. But she's from Colombia. She's equatorial. In any case, what is it, 23 degrees? What temperature is it in here approximately?
24.
24, okay. Sorry, I'll get to you in 1 second, sorry. So the thing is that actually, there may even be a thermostat in the room. We could actually go look and see what temperature it says. But that isn't actually the temperature in the room. Like if we go over here and we touch the windows, if we put our hands right by the windows, right, I can already feel my hand colder just inches from the window, right? If I put my hand next to my computer fan, there's a different phenomenon coming out of it, right? And so there's one temperature in the room. It would be a mistake to think that that is some independent number. The only way we can get really data that has integrity is if we connect that data to its source. So let's suppose I have a little infrared thermometer that I can read the temperature readings with, and I take some readings around the room, right? And then these are submitted to the database that Arthur has, taken these readings using this device and submitted them. And now we find out that this device is 20% out of calibration, right? That all of the numbers are off by 20%. Well, if those numbers were broken from their source, we would have no way of invalidating them or adjusting them. If they were just in there as independent data, do we know that somebody else didn't change that data and now can we adjust that number or not? Or, we would suggest that no data rightfully has independent existence. It's always an assertion from a particular vantage point, just like time is. And so this is the data integrity model of Holochain, is that everything that gets put into the DHT is signed by a particular source, committed in a particular sequence, according to a particular process that is a shared process, and validated also by those same processes that everybody shares. And that's how we end up. All right, you can't do that one. So wait, let me get the question in the back of the room first.
So is this particularly for time? Because this reminds me of, as a neuroscientist, how the brain operates, not just in the time domain, but also in the space domain. Right? This is about a level of detail that is required for the group to sort of go one level up. And that level up is never caring about all of the details, the level down. So it's not just in the time domain, I suggest, but also in space. And it's really interesting.
Yeah.
Space time.
Yeah, exactly. I'm afraid to go too deep into some of the weirdness that Scepter really encodes, but these ideas are coming out of really looking at the natural world, all the way down to subatomic levels and cellular levels, and how do these things work on scale? How do we create, I wouldn't call it consensus, but how do we create coherence? How do we actually build on the stability of previous layers of coherence? And that I would suggest that for us to organize and have quantum leaps in our capacities to organize, we have to be able to build those same kinds of coherence on a human level. So
you started when talking about natural systems. The thing that makes this work like a natural system and makes a lot of this less complicated is that the natural world is characterized by its laws about how the states change, not what they are. So conservation of energy is consistent with your question about the temperature in the room, and this system is consistent in the sense that you're enforcing that you mutated the states validly without enforcing necessarily what they are. And that's how decentralized systems remain consistent in nature, because nature is literally decentralized and it's captured by natural laws.
Exactly.
And your natural laws are all in one order up. What's a legal state transition that mutates multiple states in the system. So you have that property here, you have that property in nature. It allows you to avoid the complexity of knowing, again, if I throw you a baseball and he throws him a baseball, no one cares about the fact that I had a baseball and you had a baseball. I mean, it's physics, basically, but it appears very naturally in the system that you've architected.
Exactly. So the Holochain provides kind of an underlying physics of cryptography for validating some of these things, and then an application provides a shared set of rules by which everything is validated in that context.
So I think we're getting into Q&A. If you're
Yeah.
going to want to get to the building stuff, then you need to get through this.
All the time.
It's 7:30. So we have an hour and a half total.
Yeah. Okay.
So we can dive into Q&A, but that's going to be
I want to get to the other core concepts, I think. So, yeah, I feel like something popped in the room a little bit. Like, are people seeing? I can't tell. I'm clear some people are popping in. I'm not clear who isn't. So I guess what I'm looking for is who what questions do you have if you feel like you're on the edge of sort of getting this mind shift? Because this mind shift is kind of the critical one to be able to build effectively on Holochain. And I didn't expect to sort of start getting into it in the overview, but stranger things happen. So who sort of feels like you're on the edge of getting it and you've got some questions that might take you over?
I do.
Yeah.
Could I interpret the mind shift as thinking like every concept that you would normally think, how should I say, like switching from symbolic approach to AI, for example, to connectionist, or as collective intelligence way, like every concept that you would normally just give a name and absolute existence to and track. If you then go to your system, you actually have to design it as an emergent concept that emerges from rules that are designed in your DNA. Or am I going too far?
Well, I think you're kind of on the right track, but I might try to actually make it even simpler. We have, as technologists, we have learned a bunch of practices that made a lot of sense for centralized computing, right? Like have one authoritative source of data, right? Like if you don't want somebody's phone number to be in your CRM system and in their profile on their website and in your accounting system and all this different stuff, and then when the phone number gets changed and now you have these different versions of the phone number, which one is the real one? And, right, there's a bunch of reasons why we sort of centralize these things when we're doing technology design normally. But I would assert that normal patterns of technology design started breaking down as we started getting into multi-threading and multiprocessor stuff, and then they break down horribly when you start spreading it across thousands or hundreds of thousands or millions of machines, and you have massive simultaneity and unknown sequence of events and all that kind of stuff, that it's not quite so simple. Those patterns aren't quite so simple. And so I would kind of invite us to suspend, if you're a technologist, to suspend some of the proper good training you learned for centralized computing. And when you think about building something on Holochain, actually think about how we go about it in the physical world. So, like, we had a developer that was really into governance and building governance apps and getting very freaked out by how can I collect votes on an eventually consistent system? How do I know if I've gotten all the votes? What if somebody thinks they've cast their vote and he would get really actually kind of frustrated and freaked out. And I was like, well, as a suggestion, just think about how we solve this in the physical world, right? You don't just get to write your vote on a ballot and drop it in a garbage can and hope that somebody counts it, right? Like, there's a place that we go and we actually, put these things in ballot boxes or whatever. It's like, you can make a ballot box type of agent, and until your vote is countersigned as accepted by a ballot box, then your vote hasn't been accepted. And you haven't collected all the votes until you've talked to all the ballot boxes, and you know how many ballot boxes there are. Just as an example, I'm not saying this is the way to do things, but if you just think for a moment how we solve problems in the regular world, which is unpredictable and eventually consistent if we're lucky, and like things like that, that generally speaking, it will lead you toward good design patterns in Holochain apps. So, yes, the connectionist approach, in some ways, is the way things are happening in the real world, right? In the neurons in your brain, in your body, right? That things are propagating, and there's layers of change, and there's feedback loops, and there's right. If you start thinking about things in those patterns, it probably leads you to the right way to build your Holochain app. Is that good enough for the moment? Okay. Yes. Other. Yeah.
I think the answer to this will cover ground you've already covered, but the redundancy will be helpful for me at least. A friend of mine who couldn't be here wanted to know what the Holochain equivalent or the nearest equivalent, would be of an Ethereum address.
An Ethereum address. So, well, the thing is that all data in a shared space lives here in a hash space, right? So everything is addressed by its hash. In this case, a SHA-256, so 256-bit hash, which I don't know why I always say this. I need a better way of saying it. But for those of you who believe in a finite universe, supposedly 2 to the 256 is more than the number of atoms in the universe. I don't believe in a finite universe, so I don't know why I use this example. But that's a lot of addresses. So it's a very sparse address space, and you have to do optimizations to be able to find things in it. But nodes are found in this space, and so is data that is stored in the nodes. It's all in one address space, and it's the same hash algorithm used for signing things to your chain and hashing the entries in your chain. So it's a content addressable content addressable address space, so that the hash of this entry is the address that you find it at. The hash of your public key is the address we find you at on the network. Nodes and data all live in the same address space. Does that?
Yeah. Is it the case that you have one public key per app?
It is not exactly. It is the case that you have one network key that you are registering as your address, but you may have an encryption key, you may have your authoring, signing key. Part of this, in the old version of Holochain, yes, one key. In the new version of Holochain to support Holo, which we haven't talked about yet, but which is a distributed hosting system, we need to be able to have multiple types of keys. And one big difference between blockchain and Holochain is that Holochain has key management. And what I mean by that is, in the case of blockchain, the keys are what control the tokens, right? And if you lose your keys, you're just screwed. You've lost control of the tokens. In Holochain, so your key got registered here in your user identity stuff. You also registered your public key under the DHT, which created your address here. There's validation rules around that as well, so that you can, suppose you're running a Slack app type of thing on Holochain, and you want to require invitation codes in order for somebody joining the network to be validated, right? So you can make a membrane on who can even create addresses in the space. Sorry, getting off track. Key. You can create later identity entries that revoke the previous key. The problem is, that's a native capacity in Holochain exactly this way, but the problem is that isn't the way you want it. If I lose my phone and I'm running some Holochain apps on it, whoever now has my phone could register a new key that locks me out, right? So that's actually not the key management approach you want. What you want is a way that allows me, if I've lost my phone, to revoke the keys on that phone so somebody can't act as me in the currency, right? Which we provide an app for, a native thing called, really sexy name, DPKI, Distributed Public Key Infrastructure. So you are not locked with only one key. There's basically, we don't think blockchain or any application is ready for prime time until key management is also included, because people suck at managing keys. So we have to have options of doing this stuff. UI. So we have P2P, agent-centric. I think we already covered that. Now let's talk about the layers of an app. I'm just going to do them all at once. Woot! Because this is what this diagram is really for. So when you're writing an app, what you're really doing is you're writing this code that is going to be executed for how to create all entries and chains, how to validate any entries that are shared. That's basically what it does. It also exposes some functions to interfaces, which you would use, for example, for a web interface. You run a Holochain app. If you pull up a web browser to access a Holochain app, you point it at localhost. You are your own server, right? So, and then what happens is you're talking to this code that's running. You're writing to your chain, And if you're trying to retrieve data that isn't yours, the application is reaching out to the network and pulling that data back from the DHT, from the nodes who have it. So that was really quickly what the layers of a Holochain app are. There's the code, there's the local database, there's the shared DHT, which is where all public entries are published to a footnote for later. You can have private entries that are not published to the public space. And then you are storing your little slice of the DHT, of the nodes that you're supposed to be storing, also as a local data store, so that nodes can be retrieving data from you that you're supposed to be holding. Those are the components of a Holochain app. Most of this all is just handled for you invisibly by the physics of Holochain underneath. This is the place where we write an application. Jacob.
Quick question. Will you...
Wait a second.
Thank you. Will you copy the content of your private source chain to the DHT, or will you just publish the hash of the data to the DHT? So will you have a copy of the data in your DHT database and in your source chain, or will you just have the data in the source chain and have the hash of the data in the DHT? Does that make sense?
I understand, yes. So every public entry is published to the DHT. It is at the address that is the hash, but the data that's stored there is the entry, which is what makes it content addressable, so you can retrieve the data using the hash. Private entries don't get published there, and headers may or may not get published. That is an application setting. You decide whether or not you want headers published. For some things, like Twitter or whatever, you don't necessarily care about headers. For a currency, you may care about headers because you may want people to be able to reconstruct somebody's whole transaction history and make sure they're not missing any pieces. And headers are what let you do that, even if the person's offline. You can't get the chain from them. So that's just a setting. Dustin?
How do you deal with versioning?
It's a great question. So for how do we deal with versioning? So one of the things that's super convenient about centralized systems is you only have to change the software in one place, right? When you have to update your software and everybody's coming to your server, you just update it on your server, everybody's automatically up to date. When you have decentralized and actually peer-to-peer distributed systems, and are you talking about versioning of the code or versioning of data?
Yeah, let's say I want to change my application.
Yeah,
right?
perfect.
And a new version of the application came out, but me and him are still on the old version when we do a transaction, but then them two are on the new version.
Yep.
And it's a different
Perfect. So if we were to draw another box like this one behind it, just picture a little card sitting here behind it, you can build an API bridge. You can put in an entry in your chain that gives an API key to another application to be able to make calls into your functions here in this chain. And what that lets you do is make bridges between big bridges between applications. First of all, there's a whole bunch of useful things about that, which we'll come to when we talk about a microservice ecosystem. We would encourage you to build Holochain applications as microservices and then bridge them to each other rather than building huge, complicated, monolithic apps that you make lots of changes to, exactly for this reason, because updates can be a pain. So if you can build parts of your system that are stable and solid and unchanging, those things never have to get updated. That's great. So what you do when you create a new version is you can build a bridge to the new version and do a migration code, like have migration code in the new version that says, I'm going to suck data out of the old version that I need to create basically a starting state, or I might import entries, or depending on what you need to do, you can actually bridge to the new version. You can also put a closing entry on the old version saying, I'm no longer here, find me at this new DNA at this new key, right? Or maybe you're still reusing the old key. That's your choice. Okay. I think the last thing to say, well, no, we haven't talked about UI much, but earlier I mentioned it's just web UI. We also, in the new version of Rust, are using Qt or Qt as a way of building lightweight apps that just you can actually compile Holochain in as a data library, a data service library, and you can run native apps on essentially any platform, because Qt compiles for just about any platform. But other than that, we have basically a socket that you can query, just make web queries to, just like you would be doing normally from a web server, but you do it through Ajax JavaScript calls. And you can render that into standard web UI stuff. The last thing is the self-healing network. So the nodes out here, one of the settings that you create in your code is how many copies of something you want to have live on the DHT, on the shared space. So if you're running a Slack team of 50 people, you may actually turn off sharding. You may actually say, let's have everybody hold a full copy. The advantage to that, and this is one of the things that I think is really exciting that blockchain can't do, is that you can then operate offline. You have a full copy of the code. You can read whatever threads you haven't read. You can post to those threads, post to those chat channels. And then when you connect back online, those things are basically in your outbound buffer to synchronize with the rest of the DHT. You have a fully functional app offline if you gave everybody the full copy. But suppose you're running a currency and you don't want people to make offline transactions because you're afraid of them getting snookered by somebody and you want to make sure that they can actually validate data on the network and that kind of thing. Then you don't want to set that up that way. You want to make sure that you're sharding the data, but you say how many copies you want online. Do we want 50 copies of every transaction online? Do we want 20? What level of resilience do we need? What we do with Holochain is when you first commit an entry, we do this sort of fast push phenomenon of, if you said there's supposed to be 20 copies, then we find 20 nodes that are supposed to hold it and make them hold it fast. Like we push, it's part of the eventual consistency. We're trying to make that eventual part as short as possible by getting the data out there very quickly. But there's also gossip happening between the nodes, where they are checking on each other and they start calculating uptime of each other and some certain performance statistics of each other, and they're managing the health of the data that they're holding. So if there are 20 nodes holding some data, let's take this piece of data. I've got 20 addresses that have signed it, and I'm one of them. So I'm supposed to be making sure that these other addresses are still around, but a couple of them have dropped away and I haven't seen them for a day or two. I may need to actually get some other nodes to hold this data in order to keep 20 copies online. Or if we have, let's say, average uptime of 50%, then I may need to have 40 nodes holding this data to make sure there's always 20 online. Does that make sense? I'm seeing a few. Okay.
Question about it. I'm sorry.
Yeah.
But the problem I have, not really a problem, but that's going to matter as much about the topology of the communication network as the number of nodes. So if you get a bunch of 20 nodes that are all talking to each other and the communication network has a bunch of people who want them that are far away, it's going to take a long time. If you take the same sort of 20 nodes and you actually get them spread out through the network, you're going to get a completely different set of properties. So how do you manage the spatial element of this?
Yeah, so there's, did everybody hear his question about the topology? So there's actually, we consider what you're talking about a good thing. And what I mean by that is, first of all, if I'm a node you're trying to convince me to hold this thing, and I have data because there's a nearness algorithm in the DHT, which is you do an XOR between the address of a node and the hash address of the data to find out how near they are to each other, basically, and that's how you determine who's supposed to hold the data. So if I'm near these nodes and I have different data about their uptime, because I'm in a different sort of segment of the network, then I'm like, no, you're wrong, I don't need to believe you. But wait, there's another part of this that's really important, which has to do with, the projects in Africa where they have like people bicycle through the town with a Wi-Fi router, and it's like, then people synchronize data and that kind of stuff. Part of what we think is possible with the self-healing network type stuff is this propagation of movement through networks where you actually want to be making copies of things in areas So we actually consider that to be a.
That's what I was wondering. It seems like you're imposing the notion of distance, whereas the notion of distance should emerge based on who wants it, as opposed like I'm trying to figure out whether you have the notion of distance sort of projected on them, or whether the distance is sort of like if it's near people who want it, then it's not very far. I'm not going to get
Distance has nothing to do with network topology in this. It's hash topology, which makes it random, right? So you basically don't know what the hash is going to be, which means the nodes that are going to validate the thing you just created are random, and you don't know who they're going to be.
Distance. It's not topological distance at all.
No, it's hash distance. Yeah, we don't need holochain versus blockchain, right? Basically, is that kind of clear?
Yeah, holochain one.
Holochain one. Okay, great.
We've gone through that online a bunch.
So, really briefly, Holo versus Holochain. There's some brand confusion between some of our projects, and that's maybe our fault for naming them so similarly.
It's certainly not anyone else's fault that they were named so similar.
Holo. So, Holo is an application. It's a Holochain application built on top of Holochain. And the job here in Holo is like where the crowd is the cloud. This is about basically creating, basically having Holo be the Airbnb of cloud hosting. And what I mean by that is Airbnb competes with the largest hotel chains in terms of the number of bed nights sold, and they've never built a hotel. We think that we can actually use the scalability of Holochain to tap into computing power everywhere, wherever it is. Idle computing power that we can incent people to run and earn cryptocurrency for providing hosting, that kind of thing. We think we can actually basically do the same kind of thing where we can compete with the big cloud hosting companies and never have to build a data center. So Holochain is this neutral platform that has no currency built into it. We believe it should not have a currency built into it, just like the internet protocol should not have a currency built into it. It has to be neutral so that you can use it for any purpose or build any currency on top of it or any application on top of it. We also believe that it doesn't fundamentally need a currency because it carries some of its own incentives. It's like Dropbox doesn't pay you for you to keep a copy of your files. You already want a copy of your files. You want to control your data. You want to control your identity, right? We think that that is, in most cases, a strong enough incentive for you to be able to run, for example, a peer-to-peer Twitter and actually own your data, own your identity, not turn it all over to Facebook or Twitter or Google or some other megacorp. The ability to control that stuff yourself and fork, go in a different direction if you don't like the way the community's going. Matthew will probably talk about that when we break out. But Holo is a different project than Holochain, and Holo does have a currency. And Holo did an ICO, and Holo is building this hosting framework on top of Holochain. And then there was one question, let's answer that one right now as well, about can you run HoloHost on a PC? The answer is yes. We haven't released the HoloHost code yet. We have built prototypes of all of the Holo components, basically, on the Go version. None of them are going to be the live versions that we release because we have to rebuild those on Rust. But even internally, we can't build on the Rust code. The Holo dev team can't build on Rust yet because the Rust code hasn't been ready. So we've basically prototyped Holo on the old Holochain, and we are starting. We're not quite finished prototyping Holo on the old Holochain, but then we will start porting that all over to the new one, and that's the one we're going to release. Yeah.
Forgive me if this question is naive, but with the Bitcoin network, it's secured by miners who spend real energy to calculate hashes that ensure that there's a data integrity across the network. How does that work with Holochain?
So that has to do with consensus. So there's two consensus algorithms that are mostly popular in the blockchain world: proof of work and proof of stake. In this case, you're talking about proof of work. what they are securing is the consensus, is the agreement about this inventory of data, right? You don't, if we go back to the architecture diagram, I'll just Alt-Tab. Sorry. If we go back to the architecture diagram, you are the only one who can write to your chain. You are the only one with your private key that can create a transaction on your chain. So unless you've compromised your private key or cryptography doesn't work, right? Which then we have the same problem with blockchain. So this isn't unique to Holochain. Nobody can counterfeit a transaction on your chain. We don't have to worry about somebody spending your coin or creating a right, because they have to be able to write to your chain with your private key, sign it there, and publish it to the DHT. So we have a fundamentally different model here. Those things are about the consensus of building in absolute time, of whose blocks can we believe, right? And if you can take over the computing power of the network, then you can do a 51% attack, right? And manufacture blocks faster than the rest of the network, and that's the attack. So I'm going to say something that's sometimes, I don't have the sense we have a lot of Bitcoin maximalists in here. Is that true? Okay. A bunch of people talk about Bitcoin being backed by the electricity use. And to me, as a currency geek, like I've been designing alternative currency systems for a long time, part of it is the use of the language, right? Like to me, a currency is backed by something only if it's redeemable for that thing. And you can't redeem Bitcoin for the electricity that got wasted in protecting it. So it's not backed by electricity. It's secured by the electricity. But the problem is that this is the data integrity model of Bitcoin, which means even as computers get more and more efficient and all that kind of stuff, that means we have to make the hashing algorithm harder and harder, which means it will always be inefficient. It will always use up this power. Like right now, Bitcoin is using 0.5% of the planet's electricity to do 5 transactions a second. You know, this doesn't work. You can't scale this kind of architecture. And yes, Matthew wants me to calm down on these statements.
Can I just make visible how we do the data integrity thing? So there's a couple of things. One, Art talks about the DNA and code, and this is where you're going to be working and building apps. The core thing there is these are shared rules. There's some other stuff too, but the main thing is you're agreeing to play a game with some other folks by a specific set of rules. If you're playing Twitter, those rules might be, hey, you're only allowed to send messages that are 140 characters or less. If you're playing poker, the rules might be, if you've got 3 of a kind, it beats a pair. And things like that, right? But it's about those rules, and validation has to do with us enforcing those rules. For me, I actually like the card game analogy for making visible how something that's organized like this can enforce data integrity, can avoid the kinds of problems that people are using mining in the blockchain world to solve. How many of you have played cards at home with friends? And how many of you hired a referee? How did you keep them from cheating? Yeah. We all understand this. The issue is, okay, we didn't need a referee because each of us was holding on to the rules. We had agreed about the rules. Sometimes when I play cards with friends, and I don't play cards that often, but sometimes every different round, there's a new person dealing, and that person gets to choose which game we're going to play. Right? They go, this next one is 5-card stud, right? Or 2 wilds, 2s and 4s. And everybody goes, come on, man, 2 wilds. But what's happening is we come to agreement about the new rule set. Those rules live inside of us. I'm remembering, yes, 2s are wild, 4s are wild, right? And when somebody lays down ace, ace, 4, I read that as 3 of a kind. And so does everybody else at the table. Now, what happens if somebody tries to cheat, if we have an attempt at violating the integrity of this game? What happens if somebody tries to pick up a card when it's not their turn? Right? The first person who notices that there's a problem, the first person that notices that there's some rule violation occurring, does two things. They might do them in one action. Hey man, it's Billy's turn. Right? But when they do that, they are signaling to others. They're letting the other people at the table know, hey, there's a problem here. Pay attention to this. And they're moving to take action themselves. Same thing happens in a Holochain app. As soon as somebody starts trying to propagate bad data, maybe it's a Twitter-like app and they're sending a video file instead of a 140-character tweet, the first person that lands with goes, hey, wait a minute, this isn't okay. You're not, that's not playing the game that we're supposed to be playing. Or if they were trying to spend money that wasn't in their account, whatever the rule violation is. And that party does two things. It signals to others, hey, there's a problem here. And they can send the proof. This guy, it was signed with their little private key. And this other party doesn't have to take my word for it. They can check their own copy of the rules. They check the signature. Yep, he said it was fine. He tried to pass this thing around. Nope, that violates the rules. Yeah, that guy is trying to cheat. And what do? They repeat the same process. They signal to others and they move to take action. What does that taking action look like? It could look like, I'm not going to receive any stuff from that guy anymore. I'm not going to send him any stuff. I personally am going to stop treating this bad actor like he's playing the same game that we are playing. And if each of the other people also decide to treat that person like he's not playing the same game we're playing, he's been removed from the system. That attempt at cheating was thwarted. It's the same in a card game. Somebody picking up a card will only profit them if the others will continue playing with them. Right? So this process we call an immune system response. It's not just how we handle failures in card games, it's how our bodies handle threats as well. But that's the underlying model that we're relying upon for Holochain and data integrity.
Cool. And what we call that in the DHT is a warrant. You can take somebody's signed attempt to do a cheaty transaction, right? I'm going to make a fake account and have it send me 1 million credits that it doesn't have, right? And so now both parties sign that transaction, both parties get warranted, people can start adding it to their block list, and we just drop their packets and no longer play with it. Jacob.
So if I try to publish bad data and it gets rejected, is it a simple matter for me just to deleting that entry and I can start being back in the game, or will I be locked out forever?
This is one of those domains where I don't think we have used the warrants enough to answer that question. The short answer is you can't really delete things in this space. You can mark them deleted, but this is a monotonic space. Right? It doesn't go away, and there's a reason for that. It has to do with the gossip protocols that if you actually delete things, then you don't know what order the add is going to come versus the delete and that kind of stuff. You end up in these weird cycles, and you can't do the gossip properly. But if you keep it and you mark it deleted, then anyway, it's to do with what it takes to actually create eventual consistency on a gossip system like this. Cool. So what we want to be able to do is start switching to actually the breakout, I think. So we want to get hands-on this weekend, and we've been a bit theoretical. Raise your hand if you still have like some, yeah, let's break into the two different spaces, because some of the questions are going to be technical, and some of the questions are going to be still high level. And this is where we can actually split into those two groups. And if you should stay in the room if you want to start designing a Holochain application. We will answer some more technical questions in here as well. And then you should follow Matthew. And who wants to go with Matthew? Anyone else want to?
If you want to, let me guide you.
So, if you are fairly thoroughly convinced that you have no interest whatsoever in building,
right now.
you're not ready to build now.
I
We will
understand.
do this again tomorrow morning.
Okay.
Yeah.
Okay.
Just for right now.
Okay. Then come and chat with me.
Cool. Yeah, cool.
I was actually wanting to say, high level stuff you'll be able to get over the weekend. Like people will be around. Like we will be around to have that as well. So I'm encouraging the technical stuff.
Sylvie?
I would love to start building, but I'm quite sure I won't be able to. So which group should I be in?
Yeah, if you're not ready at the moment to go, like I'm suggesting if you come for more of the weekend, you'll get ready to build something.
Cool.
But if you're not ready yet, go with Matthew, and because you don't know, it won't be relevant to you. Can't absorb it yet if you're not ready to start thinking about how to build something.
I'm going to introduce a thing. It's a cool way to transition from like sitting, focused, listening energy to okay, we're going to move and do something, and want to have a quicker transition so that we're not spending a lot of time in transition. So if everyone takes their hands, take your hands, raise them up if you have them, take them apart, like all the way apart as much as you can. Just get in your neighbor's space, and then think really quick. Am I going to be in this room, or am I going to be in the next room? No wrong answers. Okay, have your answer in your head, and as soon as we clap our hands, those are the places we go. Ready? All right, great. Okay. I don't know.
Right, this is the end of the live stream. Thank you very much for watching, and see you soon.